The last function that we need to work out how to integrate or find an antiderivative for are circular functions or trig functions. So let's just quickly go through how the rules come about. So let's focus on this one first of all. If f of x equals sine x, then f dash x, we know from calculus, equals cosine x. That means that if I integrate cosine x dx, that is, if I get an antiderivative, I'm basically asking, hey, what were you before you were derived? And that's what the answer is. It's sine x. So that's what this rule says here. If you antiderive cosine ax dx, you're going to get sine. And this a value here, I'll explain how that comes about as well. So don't worry about that just for the moment. All we need to know is that when we antiderive cosine, we get positive sine. Now, the other rule is g of x equals cosine x. Now, what was the derivative for cosine x? Hopefully you remember that it is negative sine x. What that means is that if I antiderive negative sine x dx, I'm going to get cosine x. That is, if I antiderive this, it'll take me back to what it was, which is this. Now, remember that one of the rules for integral calculus is these values here, the coefficients can come out the front or float to the front of the integral. So I can write that as negative sine x dx equals cosine x. And I can divide both sides by this negative, which means that if I integrate sine of x dx, what I'm going to get is negative cosine of x. All right, and that's this first rule. So when I integrate sine, I get negative cosine. Again, I do this thing with the a values. That's kind of how the rules come about. Can I just make a strong suggestion that you use the formula sheet for these rules? I find students start to get confused with when the negatives and positives come out, because when you antiderive, the negatives go on a different thing. When you derive, the negatives go on other things. So your best bet when you get to the trig questions are to get your formula sheet out and use the rules to do it. Anyway, let's go for it on this first problem here. So we want to antiderive 5 cosine x dx. So I'm just going to grab that 5 out and antiderive cosine x dx. All right, so that is 5 out the front. Now, what is the antidiff of cosine? So I'm looking at my formula here. The antiderivative of cosine is sine. So it's sine x plus c. All right, now what do we do in this case here? Like, what comes out the front, what gets divided, etc., etc. So your best bet is to do a U-Substitution to help you with these ones here, because the formula sheet won't actually help you. Anyway, let's go for it. So we're going to rewrite this as equals 5, integrate sine 3 take 5x dx is our first move. Right, so this is the chain rule here. We want to reverse up the chain rule, so I like to do that via the U-Substitution. So integrate the sine of u, that is, get this to be something that I do know how to antidiff, where u is 3 take 5x, du dx is equal to, what, negative 5, and that means that dx is going to be du over negative 5. So that dx gets replaced with this thing here, which is du over negative 5. Okay, this negative 5 will float to the front to become negative 1. That's going to be 5 over negative 5, which is negative 1. Now, the antiderivative of sine. Oh, what's sine when antiderived? Look up your formula sheet. Sine when antiderived becomes negative cosine. So we're going to write multiplied by negative cosine, and then we'll do a u-sub at the same time, which is 3 take 5x plus c. Now this is a negative times a negative, which is a positive. Cosine 3 take 5x plus c. See how your calc goes with that one. So shift and open your brackets. 5 times cosine 3 take 5x. And what did we get as an answer? Typed the wrong function. Sine, cosine, interesting. Okay, so they've done an interesting thing here. So this is a cool thing to see, right? So what they've done is they've rewritten this as negative 5x take 3 plus c. And then what they've done is dropped that negative. Now this is important. And there was a question that looked at this in a paper a couple of years ago. Now, why can I just drop that negative? Well, this is a cosine graph. And what's happened to this cosine graph is it's been reflected in the y-axis. Now, if we think about cosine, it looks like that. Now, the thing that you kind of need to be aware of is that when you reflect cosine in the y-axis, it's exactly the same. So there's no point reflecting cosine in the y-axis. Hence, I can just dump this negative sign right here. So that means that that is also a correct answer. This would be perfectly acceptable as an answer as well. Okay, so this question here asks us to find the antiderivative of cosine 2x and then find the signed area between pi on 4 and 0. Just to see what is going to happen. The period is 2 pi over 2, which is pi. The scale is pi on 4, so pi on 4, pi on 2, 3 pi on 4, and pi. Okay, so amplitude is 1. So the graph is going to come down like that. Okay, so they want the signed area between pi on 4 and 0. So that's going to be this area here. So the signed area in this case is going to be the actual area. So let's go for it. That is going to be, so the formula sheet will tell us that it is going to be 1 over 2. So that 2 is divided by whatever the coefficient of the cosine is here, which is 1. And cosine, what does cosine become when anti-diffed? Cosine becomes positive sine. So that's going to be sine 2x. All right, what we're going to do is pop that in some square brackets and put our terminals on there. All right, now this half here can actually come out of the square brackets. And then what we'll do is we'll sub pi on 4 in. So that's going to be the sine of pi on 2. Take away the sine of 0 goes in. 2 times 0 is 0. The sine of 0. Probably over bracketed there, but never mind. Now the sine of pi on 2, that's 1. Take away the sine of 0 is 0. So 1 take away 0 is 1. Half of 1 is a half. So half is the signed area. It's also the actual area. Let's just check that out and make sure I got that right. So don't forget that Math 2 has the integral functionality. So shift and 0, pi on 4, 0, cosine 2x dx. A half, that's good. Hey, good problem to do. What would be the area, the signed area that is, from pi on 2? That is, what would be the signed area if I did this? Or what would be the answer to pi on 2, 0, cosine 2x dx? Pause the video and have a think if you want. Okay, so if you unpause it now, here's the moment of truth. What should happen is that this will be a positive signed area, this will be a negative signed area, and they should offset each other because these shapes generated by the function are the same shape. So the answer to this actually should be 0. Let's see. Oops. 0. Okay, so there it is there. So your exercise is 11G, and again, just to stress, make sure you use the formula sheet.